Good morning, Year 6, and welcome to Maths this week. So it is the 1st of March, can you believe it? And we are going to spend 3 more days on ratio before moving on, just to make sure that we have revised all the elements that you learned about last week, especially because it's brand new learning ratio when we get to Year 6. So let me share my screen with you and then you can get started on your first 6 questions. Pause the screen, do these on paper, really carefully thinking about the methods you'll need, and then we'll go through the answers. Okay, let's start going through then. So 600 times something is 30,000. So the first thing I need to do here is think about the place value element of this question. I can see that this is a hundreds number with 2 placeholders, and this one is a tens of thousands number with 4 placeholders. So straight away, I can see that actually whatever we're timesing by is going to have to involve place value. Now we don't know how many yet because we haven't done our working out. So what I would do is kind of cancel out the same on each side. So if we're pretending those 2 placeholders are not there, and these 2 placeholders are not there, it would say 6 times what is 300. Now this one's a little bit easier for us to work out. Now, if you're struggling to do that mentally, you can just put it like this. 6 into 3 doesn't go. 6 into 30 goes 5 times, and then we have our 0 on the end. Now, because we have cancelled out on both sides exactly the same amount, we actually don't need to add any more placeholders, but I definitely want to check that that is correct. Now, if we saw this question without the answer, we would do 6 times 5 is 30, and then we would say 1, 2, 3 placeholders. There we go. So I hope you saw there why you can't just rush and think, oh, right, I need 2 more placeholders. Actually, the third placeholder comes from 6 times 5 is 30. Okay, common denominators, fifths and eighths. Again, there are other things you could go to, but I'm going to go to 40ths. 5 to get to 40ths is times 8, so 4 times 8 is 32. And this side, 8 times 5 is 40, so 1 times 5 is 5. Add those 2 together, because it was adding. I don't need to do anything more with that. Oops, 37 over 40. Okay, converting between fractions, decimals, and percentages. So 2/5. Now, if it's not a known fact yet and we haven't drummed it into you, the easiest thing to do is think of this as tenths using equivalent fractions. 4/10, right? Everything else now is nice and simple because 4/10 as a decimal is 4 in the tenths column, and 0.4 and 4/10 as a percentage is 40%. Ordering these in ascending order. Now, I always turn all of them into percentage. It's the easiest one for me to do. Now, 3/4 is a percentage. I know that. That's a known fact, is 75%. Now, this is that tricky one we kept telling you about, the 0.125. It is 8. As a percentage, sorry, I was about to do it as a fraction, would be 12.5%. Timesing that by 100 helps me there. 0.6 is 60, 6/10. That one's already percentage. And then 1/5 is 20%. Now I can put these in ascending order, going up, ascending order. So I start with my smallest. I'm going to type this instead. Then the next smallest would be 1/5. I'm putting them back into their original form. Then it would be 27%. I'm going to have to move this over a little bit to give myself more space. Then, okay, now I've got a little bit more space. So I had my original numbers, 0.125. I've got my 1/5. I've got my 27%. Then it would be my 0.6. And then my 3/4 in ascending order, going up. Okay, a little bit of negative numbers now, 3 minus 8. So I'm hoping if you found that tricky that you went to your number line. I would take away anything to get to 0. And then I've taken away 3, but I was meant to take away 8. So what's left? minus 5, which lands me on minus 5. Right, let me get myself some space for this last question. Make it a little bit bigger. So write the 2 missing digits to make this subtraction calculation correct. So remember, we work this just as if we were doing this without any missing numbers, starting with the ones. 9 take away something is 6. Nice and simple there. I don't just skip to the next missing number. I have to go to this because it might need regrouping. And it does, because 2 take away 7 is not just 5 automatically, which means they must have, I don't know what it is yet, but they must have taken 1 off there and brought 1 over here, because 12 take away 7 is 5. So now I've got to think, what would this be? Now I'm going to use the inverse. 1 add 4 would be 5. However, I already took 1 away from that, which must mean that the number underneath was originally 6. So the actual answer we want is 6. If you got caught out on that one, it's because you skipped straight to this one and wrote 5, but you have to remember to take it column by column as you normally would. Okay, so my big question today is about a recap from last week to see what you remember. So pause the screen on this question, have a go and see if you remember ratio and simplest form. So in a bag of red and blue marbles, there are 24 red and 12 blue. Write this as a ratio in its simplest form. Pause the screen, have a go, see what you remember from last week. Okay, so I'm not going to draw all of the marbles out on our bar method because that's not quite what's needed in this, but in ratio, we're saying how many of one to how many of the other. So writing it as a ratio, quite simply, is saying there's 24 red to 12 blue. But this bit here, I hope you remembered, it's the same as fractions. We need to divide both by the same amount to get to our simplest number. Now I can see that both of these can be divided by, actually let's jump all the way up to the, oh, they can actually both be divided by 12. That's going to get me my simplest answer even quicker than dividing by 2 or 4 or 6. So I'm going to divide both of these by 12. This is just a bit of a revision from last week, which would give me 1 on this side, and it would give me 2 on this side. Now, there is nothing simpler than that because they can't be divided anymore. So the simplest ratio for red to blue marbles is 2 to 1. And remember, we use that, that colon to mean 2. 2 to 1. Now, I know that's confusing with those numbers, but it means 2 red marbles for every 1 blue. Okay, let's just go over some of that vocabulary again then. So ratio is expressed like this, as I just did on the previous. If there are 3 blue for every 1 yellow, we write 3, that colon, and then 1. So the way we speak that though is there are 3 blue to every 1 yellow. Simplifying, sorry, is what we just did. And it is where we divide both sides using the common factors that they have, and the greatest common factor will do it in the quickest way, to find the most simple ratio. So as you can see here, there was a ratio of 5 to 15. Both sides were divided by 5 to finally get us the ratio of 1 girl to 3 boys. That is the simplest ratio in its simplest form. So those are the bits of vocabulary you learned last week. So let's get back into it then. We're going to today, you have done questions similar to this before, but today I really want to revise the use of ratio in word problems. So I'm going to do a couple. Here are the steps to success, how we solve those ratio word problems, and you can follow along with me. My biggest message to you today is whenever possible, use the bar method because it really helps that visual. Okay, so we have a packet of Skittles, lucky them, and it's a ratio of 2 to 3 for red to blue. Now, straight away, I'm going to draw that as a bar. So altogether, I'm going to try and do the right colours. There were 2 reds, I'll draw the lines in after, to every 3 blues. Now that won't take you long to draw, and it's very important to have that information. Okay, now I can keep reading. The whole packet contains 15 sweets. Now that's important. I'm going to go like this because the whole packet has 15 sweets. How many are blue? Now with my bar, I can really easily work that out now. So there are 5 equal parts, 15 in total. So if I, look here, do 15 divided by 5, sorry, because that's how many pieces there are, we would get 3. So each one of these parts, because they're all equal, same as fractions, is 3. And then for how many are blue? 9 are blue. Okay, if you want to pause the screen to have a go at this one before I get to it, you can. Let me just try and make this a bit bigger. How can I make that big? Okay, I hope that's a little bit bigger for you. So Beth mixes 2 parts of red paint with 3 parts of blue paint to make sure she has purple paint. If she uses 12 parts of blue paint, how much red paint did she use? So let's follow our steps here. First thing is to write our ratio that we know. So we know that it is 2 red to 3 blue. Now, before we think about drawing a bar, you can actually just label things up here as well. Right underneath the new number. So we now have 12 parts blue. Now it's important to really flag that because you don't want to write it on the wrong side. So if she uses 12 parts of blue paint, how much red? That's our missing number. So use multiples to work out what has been times or divided. So here we are. That has been times by 4. That's the same as we do with fractions. And therefore, we have to do the same to the other side, times it by 4. We change to red for the answer because 2 times 4 is 8. Hopefully you got that if you paused. Now, the 2 questions I just showed you are the 2 types of word problems. One is where they'll give you a fraction, a ratio, sorry. They tell you about the whole amount, and therefore you can use your division to work out each part. This is the other type of question where they give you an original ratio. They tell you how many of one of the parts there is now, and then you need to work out the other missing one. With the whole one, the one I did first, drawing the bar is vital. This one you could have drawn a bar, but actually just drawing the ratios is absolutely fine. So now I want you to pause the screen and you have one of each of those. One where you know the total, which is the sweets, and one where you know one of the parts and you need to work out the other. So for this one, follow the ratio steps where you write the ratio, write the part underneath and do your multiples. For this one, you must draw a bar method. So I'll pause the screen here and then we're going to go through these. Okie dokie, let's go through this first one. I'm going to move that picture so I've got some space. In one season, the ratio of goals for and goals against in Chelsea's matches were 5-3. I'm going to write that ratio out here a bit bigger. So this was 4, so I'm going to do green, so they scored, and against here. Doesn't always have to be the full words, anything that makes sense to you. If Chelsea scored 80 goals, which is the ones they scored here, I'm going to draw that in green. How many did they concede, which would be this side? Now I can see what type of question this is already, and I'm going to go like this. And then we have got to use our multiples, and we can use bus stop if we're not sure. What has it been times by? 5 into 8 goes 1, it's remainder 3. 5 into 30 goes 16, means it's been times by 16. So therefore on this side, I need to times by 16. 16 times 3 is 48. And therefore the answer to my question is 48 goals conceded. Okay, now let's try the other type of question, see if you got this one correct. I'm guessing from the fact that this was the missing ratio that this is going to be a bar method one. I'm going to start drawing it already. Okay, Emily has a packet of sweets. For every 3 red sweets, there are 5 purple. So let me get my lines out. 2, 3, 4, 5, 6, 7, 8. Now let's write that in. So 3 red sweets and 5 purple. Okay, if there are 32 sweets in the pack in total, how many of each colour are there? And use that bar method. So if there are 8 parts, equal parts, I can do 32 divided by 8, which is 4. And now I can use that because each of these is now 4. So therefore red is 12. And 1, 2, 3, 4, 5. 5 times 4 is 20. And you can just make sure that those things actually add up. They need to add to 32 is a good checking method. Well done, guys. I'm hoping you tried each one of those type of questions. Before we start with our activity then, I've got a where did I go wrong question. So the question said, a painter mixes blue and white paint in a ratio of 3 to 1. There are 12 litres of paint in total. How many litres of blue paint are there? So I did 12 divided by 3. And then that gave me 4. And then I did 4 times 3 because the blue is 3 parts. That gave me 12. So pause the screen. Try that yourself. Draw any methods you need to. And then I'll come back and talk about where did I go wrong. Okay, so first things first, it is a in total kind of question, which means we needed to have drawn the bar. So there was 3 parts blue. Let me just cut this up. Doesn't matter about how you do it as long as it makes sense to you. 3 parts, blue to 1 part white. Now I haven't got white, so I'll do it in black. There are 12 litres in total. So how many of each? So the steps were we take the total and we divide it by how many parts they are. Now I divided it by the 3 blue when actually I need to know the equal parts by dividing it by 4, which would have given me 3 for each part. And therefore how many blue would be 9. Now straight away I knew something was wrong because there's 12 in total and I got 12 as an answer for blue. So it was quite easy to see something was wrong, but that is where I went wrong. You need to divide by the total amount of parts. Okay, your turn now, guys. So if you're working from home, there is a Teams quiz of those type of questions, both types. And in school, you've got a word problem worksheet. Now the questions look like this, and it is so important you keep drawing the bar method. So similarly to the one previous, Nicole mixes 2 tins of red paint with 3 tins of white. She needs 15 tins of paint all together. Now when you see that word, you know you need to draw a bar. How many tins of red paint does she need? So anytime you see that word all together, it is definitely bar method. I'm not saying bar method can't be used for the other type of questions, but they are definitely needed for anything where you know the total and you're trying to find the parts. So when you're drawing your bar, you need to add the parts together, and that's how many sections you would draw. So for this one, there would be 5 parts to my bar method. 1, 2, 3, 4, and then you can label them. Okay, so when you finish your task, if you would like any challenge questions, I will leave these up on the screen for you to pause and have a go. But really well done, guys. I hope this was a good reminder of all the ratio work you did last week. Well done, and I look forward to seeing you tomorrow for more ratio questions.